Okay. I'm recording this video really quickly, just to show you the step-by-step process on how to make state machines, not state machines, what am I yapping about? Subsystems, and how to apply them in your teleop. This is for those who weren't able to make it to the in-person meeting. So first thing you want to do is in your subsystems folder, you want to create a new class. Class is it's just a Java file, sort of. You want to give it the name of your subsystem. So I already have a bunch made, but I'm going to make one called shoulder. Then what you want to do is name your states, public enum, and then shoulder states. This is specific enough. This is good. And this follows Pascal casing naming convention. Then you want to list out the values of these. So you could have it be, the shoulder could be downwards, forwards, upwards, which should be like where it's resting. And then I'll say one for, what's called, bucket. This one is just for like backwards scoring the bucket, and then I'll say chamber intake. Okay, this would be like fully backwards. Next thing, I'm going to name the current state that it's in. So I'm going to create a variable for that. You can do this by naming the states you're talking about. Give it a name like current shoulder state equals, and then whatever you want it to be your starting. You like to have it start as its resting position, which I have set to upwards. Next thing you want to do is, technically this doesn't really matter yet, but I'm going to create my servo positions, public static double, and I'll explain what this means in another time when we do FTC dashboard. I'm going to say shoulder downwards position, and I'm just going to give it a random number. I don't know what it's actually going to be. Shoulder forwards position. Shoulder upwards position. Shoulder bucket position. Shoulder chamber intake position. This is probably too wide of a motion, but again, we don't know. We can change these numbers later. Then what I'm going to do is create my servo. Since it's a shoulder, it's going to have two servos first. So right servo, I think that's fine. Right servo, left servo. I'm going to make mine right dominant, which means these positions are going to be for the right servo, and the left servo will be like the reverse of that, or the inverse of that. Then I'm going to create my first method. Initiate method. And your inputs are the hardware map. What this does is you can set your servos this way. Hardware map.servo.get. Then the name of it is probably gonna be called like right shoulder or something like that. And we're gonna do the same thing for the left servo. Then we're gonna have a method to get the current state. Oh wait, sorry. Set the current state. Public void set current shoulder state. And then you want to have in here the value of new shoulder state. Basically, let me explain what this does once I finish it. It sets the current shoulder state to the inputted state. So this way your teleop can modify the current state of the shoulder. After that, we're going to have our update. You can call it update, loop, whatever, run, something like that. And what we're going to have is a switch case statement that's going to check the current state of the shoulder and set positions based off of that. So case, and let's just start with downwards. Then what we can do is have the right servo.set position, because I'm having this right side dominant, like I said, and then shoulder downwards position. Left servo, that's the position. 1 minus right shoulder. Because you gotta remember, that servos are, the positions are from 0 to 1, which means you can't do like this way, because that would be below 0 so you have to do it the other way, 1 minus that number. So if this is 0.3, this would be 0.7, so they're reverse of each other. And then what we do is we just do this for every single state. And I don't remember how many I did, but whoa, I'm gonna just, let's start with this one. And then the final one. Okay. That's all we have to do here. So we finished the subsystem. Now let me explain what everything does. This is your class. This is your subsystem, okay? So we're talking about the shoulder. These are the states it can be in. It can be downwards, forwards, upwards, bucket, or chamber intake. So I call it shoulder states. Uses an enum. This is the current state of the shoulder. So the shoulder state's current shoulder state. And this is the starting state of the shoulder. So they're basically resting here. These are all the servo positions for each of these states. These are the servos. This is setting the servos. So right now the servos aren't actually equal to anything. This is just giving them an actual servo to equal to. And then this method here sets the current state of the shoulder to whatever the input is. That way we can modify the current state of the shoulder via teleop. And then here is it just sets the servo positions based on the state, whatever the current state is. On the teleop, what we can do is here what we can do is, or here, depends on, this is before it, this is when you press initiate, this is when you press start. So for teleop, I would actually recommend having it when you press start. For autonomous, when you press initiate. Let's do when you press start for now. So what we're gonna do is we're gonna have to call upon the we're gonna have to create an object for this. Well, let me show you. So watch, what was it, shoulder, and then shoulder. This is basically I'm getting the shoulder class, and I'm creating my own, like, I guess, instance of it. I'm not sure what the word is, but this is its own object here, and it's going to be a new shoulder. Then this shoulder will be initiated, and inside the loop we want to update it. So shoulder.update. This way it will run this loop, every single loop in here. So basically every time this runs, this runs. Next thing is we want to make a rising edge detector. Watch my other videos on that if you want to know what that is, but basically what we can do is get the previous gamepad. Oh wait, I already made that, hold up. Yeah, you need this line of code, but and then at the end you'd have this. But to make the rising edge detector, what we can do is do if gamepad 1, and then whatever button you're talking about. Let's try left bumper. And then it's going to check if the previous left bumper wasn't pressed. So if it currently is being pressed, but last tick it wasn't being pressed, then this is basically saying this is the moment you pressed it, which means you can do your updating. So let's just have left bumper correlate to and yeah, we would use the set current shoulder state method. And let's say we can do left bumper, seems like it would be forwards. Now you're gonna see a trend soon. Now we're gonna do the same thing with the right bumper. And right bumper seems like it would go back to resting, I think. And then left trigger. So let's try left trigger. Let me show you what left trigger does. So remember, left trigger, it gives you a number. So what we can do is actually use greater than, or greater than and equal to, and then to a number, like this. So it's basically checking if the left trigger is being pressed down more than 0.1. And then what we want to do is do the same thing here, except just the opposite. So we could use not, or we could just do the other way around. We could just do less than 0.1. So this is basically saying it essentially wasn't being pressed before, and now it is. And let's just say this is like full. Actually, let's say this is bucket. Yeah. And we can do the same thing for right trigger. And then do, like, I don't know, chamber intake. And the last one we can do, we're running out of buttons here. Let's just do cross, because that's the one that always got me. And then we can't do this. We have to just do like that. Cross, and again, you can't have it. It's a Boolean. You can't have it be equal to a number. And then we just set it to whatever's left. I think it was like downwards. Yeah. So you notice this took 5 buttons, because right now we're using a rising edge detector for each state in a state within a subsystem. It's not very efficient. So that's why in next meeting we'll talk about state machines and how we can make this way more efficient.